Today we will be discussing the topic traveling salesperson problem. So what is this traveling salesperson problem? Given a graph, you have to find a tour. You'll be given with the mute yourself. So we'll be given with a graph, a directed simple. So a directed graph you will be given. And a tour is nothing but a cycle that includes every vertex in that particular graph. That is, if you have a set of vertices V, then this tour will contain a simple directed cycle that includes every vertex in V, and also the cost of that particular tour is the sum of cost of edge on the tour, and that tour will also be minimum. So we will visit all the vertices in that particular graph, and after visiting the tour, the whatever cost if we will calculate, that will be the minimum. That is, the cost of tour will be minimum. How to get the cost of the tour? It is nothing but sum of cost of edges on the tour. So if you are moving from one city A to E, and if you have A, B, C, D, E as the cities, you will take the shortest path to move from A to E, and when we add the cost of those paths, it will be the minimum. So that is your tour. Okay, so our idea here is to find a simple tour or minimum tour. A tour is nothing but a simple path that starts and also ends at the vertex 1, or which usually starting from whichever vertex it starts, it ends at the same vertex. So it took such a long time to load. So we are discussing the traveling salesperson problem. Okay. So what do we have here? We have a graph with vertices and index. One second. So we have a graph which consists of vertices and edges, and each edge will have a cost C of ij. An edge from I to j will have a cost associated with it, which is represented by C of ij. Okay, and this C of ij is greater than 0 for all I and j, and this will be infinity if that particular edge will not belong, that if I of j does not belong to the set of edges, and the number of vertices is n, and you should have more than one vertex in the graph. Okay, and what is a tour in that case? A tour is a directed graph. It is a directed graph, simple cycle. So it's a directed simple cycle. So what does that include? That includes every vertex in V. Okay, every vertex in the set of vertices which are there in the graph. And the cost of the tour is, what about the cost? So these are the terms which we will come across in this traveling salesperson problem. The tour is the sum of the cost of the edges. Sum of cost of the edges on the tour. So that is the cost. So what is your traveling salesperson problem? It is nothing but finding minimum tour. So finding this minimum tour will be the traveling salesperson problem. Okay. So what is traveling salesperson problem? Finding the minimum tour. Okay. Note down this. So finding minimum tour. Fine. Is that fine now? Able to hear?
Yes, ma'am.
Okay. So what is our idea here? We will have one. We will have a graph. We will have to find a tour. Suppose we have a, okay, this is our 6P problem, whatever I discussed yesterday with you all. Did you execute the program? Did you people execute 6B program and check for errors?
No, ma'am.
Okay, find time and you just try executing it.
Yes, ma'am.
Okay. So we will have to find the minimum tour. And what is a tour? It's a simple path that starts and ends at. Tour is a simple path that starts and ends at vertex 1 usually. Or you can say from which vertex you want to take a tour. It should end at the same point. And every tour will have an edge 1, k. For some k, what is this k? It belongs to the set of edges leaving 1 because it starts from 1. And it will have a path from k to vertex 1. Okay. And we will get g of every time we will get g of I comma s, which is the length of, let's consider g of I comma s as the length of shortest path. It is the length of shortest path starting at particular vertex I, any vertex whenever we are starting from that vertex I, going through all vertices. So this is the formula whatever we will use, going through all vertices in S. So S will include all the vertices it should pass through. If we will take g of 2, 3, suppose if I say. So what does this mean? This means that the length of the shortest path starting at 2 and going through the vertices which are there in S, going to 3. Okay, going through all the vertices in S and terminating at 1 and terminating at 1 because it is a cycle. It should start from 1 and it should end at point 1. Fine. So g of I comma s we will use g of I comma s, that is the shortest length of shortest path starting at vertex I, going through all the vertices in S and terminating at 1 because 1 is where we start the tour and end the tour. So we need a simple cycle that starts and ends at vertex 1. And this g of 1 minus 1 comma v minus 1 is the length of. We will solve the problem. As I always tell you, you will understand better when we will take one example. When it is illustrated, it becomes simple. If I just explain, you may understand how. When I illustrate it with an example, it will be more clear for you. Okay. So finally, when we get this g of 1 minus v of 1 comma 1, we will have the length of the optimal salesperson tour. So you know that tour should be minimum. So we'll get the minimum tour when we calculate this g of. So let's write down the recurrence relation now. Optimality. From the principle of optimality, what is that we will follow, that I'm writing here. I didn't clear the canvas in the beginning. That's okay. So we will have from the principle of optimality, it follows that g of 1 comma v minus 1, maybe we will exclude 1 from the, which means that from 1 to all other vertices than 1, isn't it? This means the same. V minus 1 means all other vertices other than 1. It should visit all other vertices other than 1 and it should end back at 1. We will have minimum starting from 2 and including all the vertices till n, and we will have this formula c of 1 comma k plus g of k comma v minus 1 comma k. This is our first formula, and we generalize this one and we obtain g of I comma s is equal to minimum of tour where j belongs to s, c of ij plus g of j comma s minus j. So this is your final relation, whatever we use in order to find the shortest path. Okay. So we will use this in order to find the path, shortest path, or the simple tool which starts and ends at the same point. Note down this. Recording ಮಾಡ್ತಿರೋದಲ್ಲಿ. Okay. So let's consider the directed graph. So we'll take one graph and try to find the minimum tour. Okay. So this an edge length matrix may be given or a graph may be given. for the traveling salesperson problem. So what is a tour? It should visit all the vertices starting from 1 and it should end at 1, and the cost of all the edges should be equal to minimum. So the cost should be minimum. So this is a directed graph and the associated matrix is this. 5, 0, 9, 10, 6, 13, 0, 12, and we have 8, 8, 9, 0. So this is the edge length matrix. Okay, let's solve the problem now, which will be more clear if we will solve it. Okay, so first what we do is we will just find out the path from 1 to 2, 1 to, 3 to 1, 2 to 2 to 1, 3 to 1, and 4 to 1. Okay, that's initially where we start. So what we do is first we will calculate g of 2 to 1. Actually it is 2 to 1. This is I and this is yes, as you will see here. See here, I, comma, yes. So yes is a null set initially. So we'll consider it as terminating at 1. From 2 we are finding a path to 1. So C of 2 comma 1. So you will take this as, if you will take this as 1 2 3 4, 1 2 3 4. So 2 to 1 is how much? 2 to 1, it is 5. C of 2 comma 1 is 5. Now we find 3 to 1. It's actually yes is a null set. Here it starts from 2 and visit all the vertices in S and terminates at 1. That's what I said earlier. So it's starting from 2. As it is a null set, it's terminating at 1. So 2 to 1, 3 to 1, and 4 to 1, we are just finding it. So C of 3 1 is 6. See here, 3 to 1 is 6. And then G of 4 comma the null set. So it is 4 to 1. And what's the value here? It is 8. Is this much clear? We have to find minimum tour. So what does this graph say? From 1 we should start, visit all other vertices and come back to 1. That is a tour. And when we add the length of all these edges, it should be minimum. That is optimal tour. So using this, we will be able to find the optimal tour. Okay. So finally, we'll get the path. I'll show you that also. So initially, what are we doing? We are starting with a null set. So yes includes all the vertices which needs to be visited from 2 or from I, excluding 1. It should not include 1 because it should terminate at 1. So 2 comma null set. So 2 to 1 is 5. 3 comma null set. 3 to 1 is 6. G of 4 comma 5. It is C41, which is equal to 8. We have got that value by looking into this graph. Next step. Okay. So after that, using this 2 itself, using this formula 2, we'll move on to the next step. The next step says G of from 2, which are the, we should not include 1, isn't it? So we can visit from 2, we can visit 3 and 4. So first we'll visit 3 and find the path. Then from 2 to visit 4, what is the path we will check? Okay, so 2 to 3 and 2 to 4. So 2 to 2, 2 to 1 we have checked, 3 to 1 we have got it, and 4 to 1 we have got it. Now what are we doing is we are including one vertex in this set, yes. So 2 with combination of 3 and 4. I cannot include 1 because 1 is the starting vertex. So finally we'll include that for the last one. So from 2 we can reach 3 and 4. So 2 of 3 and 2 of 4. So see here, from this we have to take the minimum distance. Okay, so first let's calculate that. So what is this? C of ij. So this is C of ij. This is nothing but C of 2, 3. This one 2, 3 plus G of j is 3. This is j. So 3 comma s minus j. So what is there in yes? It is 3, right? So what is 3 minus 3? This becomes 0, isn't it? So if we will just look at this, this part becomes 0. That is because j is 3, j belongs to s and j is 3 here, comma. In s also we have 3. So 3 minus 3, this becomes null set. So this becomes your null set. And now we can just take down the value here and that gives the path. So C of 2, 3, C of ij. Okay. And this how C of ij 2, 3 plus G of j is 3, comma s minus j. Yes also contains 3 and j is also 3. So this becomes null set 3, 5. So C of 2, 3, what is the value? 9 plus, you know the value of g of 3, 5, that is null set. It is 6. 9 plus 6. So the value here is 15. Now calculating this, C of 2, 4 plus G of 4, 5. As we have only one, it becomes null set. So C of 2, 4 is how much? 10 plus 4, 5 is 8. So this becomes 18. Okay. So likewise, from with the 2 combination of 3, 4, with 3 combination of 2, 4, with 4 the combination of 2, 3. We should calculate here. Okay. This is what I did. I didn't clear the canvas in the beginning. That's a problem. Loading also it took a lot of time. For everything, it's just and recording also will have so many talks now. Okay. So what are we supposed to do now? From 2 to reach 3 and 4 we have calculated. In the same way, maybe start from 3. It doesn't work at all properly. G of 3, from 3 to reach 2 and from 3 to reach 4. Okay, so this becomes G of 3, 2 plus, sorry, C of 3, 2 plus G of 2, 5. Okay, and so this becomes 3 to 2 is how much? 13 plus 2, 5 is how much? 5. So this becomes 18, and here C of 3, 4 plus G of 4, 5, and this becomes 3 to 4. It is 12 plus 8, and this fourth one. So this is 20, and now with 4 we have combination of 2 and 3. So this becomes 4 2 plus g of 2, 5. Getting? So as I'm not asking, no one is replying also.
Yes, ma'am.
Okay. Now g of 4 2. Look into the graph here. So 4 2 is how much?
8 plus 5.
Yes, it will be 8 plus 5, 13, and 4 3 is how much?
9 plus 6.
9 plus 6, which will be 15. Okay. So first we started with null set. Then we started including 1 1 from 2 with 3 and with 4. 3 means 2 4. 4 2 3 1 1. Now next step is we will include 2 2. Okay. So we'll include the set S will contain 2 nodes. If I will clear the canvas, whole thing will go. Okay, lot of editing I should do with this video today. So next we'll compute g of 2 with combination 3 4. So now what happens? So we should select minimum value. First we'll take this combination with c of 2 3. See 2 3 c of ij. That's nothing but c of ij, isn't it? G and yes, in S we have this, and minus j. Okay, if we will, yes, the formula, what does the formula says? It says g of j comma s minus j. If you will leave this 3, you will be left out with 4, isn't it? S minus j is nothing but we are excluding this, and s includes 3 4. S and j is this, and when I say s minus j, this 3 will not be included. So this is j comma s minus j. Okay. Now in the same way for the next one, C24, because we have two values in S. Okay, C of 2 4 now plus G of 4 we will have, because j is 4, j comma s minus j. If you are not including 4, you will be left out with only 3. So already these values we have it in the, we have got it from the earlier step. You can just take those values, and if you will consider those values, just see here, c of 2 3 is how much, you tell? C of 2 3.
9.
Yes, c of 2 from previous you can just check. I am not moving it here, that's it. 9, c of 2 3 is 9 plus, see, g of 3 comma 4.
20.
See here it is 20. Yes. And c of 2 4 is how much? C of 2 4.
10. 10.
Yes, it is 10 plus g of 4 comma 3. Here we have 15. So what is this value we have to select from 29 and 25. Which is the minimum here? It is 25. Okay, we are just moving with one vertex, with 0 first, 1, 2, next 3, and then finally that is the answer whatever we get when we move to that. So we will discuss this again in the next class if required, as there are a lot of disturbance again. So what do we do now with 3? So you are left out with 2 and 4. So I'll write minimum of C 3 2, isn't it? 3 2 plus G of J, comma. So if you have taken 2, you are left with 4. S minus J, comma, C of 3 4 Ij plus G of J is 4, comma, S minus 4. So you'll be left out with 2. So if we will calculate this value, you will get, yeah, tell me fast. 3 2, 3 to 2, what is the value?
13 plus 18.
13 plus 8. And here?
12 plus 13.
12, yes, 12 plus 13. So this again will be minimum of 31 and 25, which is 25. And finally, so G of, now we will have 4 with 2 3 as combination. So minimum value C of 4 2 plus G of, so if we will have 2, then we will be left out with 3, comma, C 4 3. So this is 3. C of 4 3 plus G of 3, comma, when you have taken 3 minus J means you will be left out with 2. Then so this is nothing but minimum of, you will have 23 plus 27, the same way you do, and we have got 23. We have selected 23. So finally we have been visiting all the vertices and checking the shortest path to reach 1. So finally we will have G of, so that starting vertex 1, and to reach through this. So what is the shortest path to reach 1? Because we should have a cycle. We should start from 1, visit all these and return back at 1. So here it is nothing but minimum of the same way. C of Ij, which is nothing but 1 2 plus G of J is 2 here. S minus J is 3 4, isn't it? Okay. Then C of 1 3 plus G of 3 comma remain left out is 2 4. Then C of 1 4 plus G of J is 4 and 2 3. Now you will get the minimum path. So fast if you will tell, we can just finish this. Yes, tell me 1 2 value.
10.
10 plus, so we have 10 plus G of 2 3.
25.
Yes, 25 Next one, 1, 3 is how much? Just checking the graph. Yeah, how much?
15, ma'am.
15 plus, what do we have with g of 3 of 2 comma 4? It is 25.
Yes, ma'am.
Then we have 1 to 4. What's the value? See the graph and tell.
20.
20,
Yes, 20 plus. So this one, 4 of 2 comma 3 is 23. So we should select minimum among this. So minimum of 35, 40 and 43. So what is the minimum path? What is the minimum tour I have? 35. So what's the path here? You can just see the path. 1 second. It's a lengthy, tiresome class today. Okay. So the tour, according to this, starts from 1. See here, this is the tour selected. This is the tour selected, isn't it? So this is the tour selected. Because that's the one with minimum value. Right? So the tour starts from 1, goes to 2, and the tour once it goes to 2, you can obtain the remaining tour from this g of 2, 3, 4. Okay, so we have the long and next edge as 2 to 4. If we will take the graph from 2, it goes to 4. The remaining tour is g of 2, 3, 4. So if we will go there, g of 2, 3, 4 here. If we will go here, isn't it? From 1, we went to 2. From 1, we went to 2. From 2, we should go back here, g of 2, 3, 4, and check here, which is the minimum value here. We got it 25. So from 2, it went to 4. So it went to 4. And then again, we have selected that. And the remaining tour is g of 4, 3. See here, this is the remaining tour, g of 4, 3. We will go there and check. Here only it is g of 4, 3. So from 4, we went to 3. So 4 to 3. And again, we went back to this. This optimal tour is 1, 2, 4, 3, 1. The path you'll get it from here. So how do we get it? By moving on like this. See here, we should trace back. Right? From 1. See, we got this selected. So 1 to 2, then we should go here and check from 2 where we are going. To check where we are going. So when we went there, we saw that here the minimum value is this 25. So we got to know that from 2 we went 4. So to find one more edge, we should go back to g of 4, 3. When we went here, we understood that we should take the cost from 4 to 3. We took it. And finally, this is the path 1 to 4, 3, 1, and the cost is 35, as you all know here. Is that clear? One more example I'll give you. You can try with that, where it will be more clear for you. If required, we'll do it in the next class again, this one, if many people wouldn't have understood. Okay, so that's all for today. Okay, lot of it's taking such a long time to load everything today. Don't know what's wrong. Yes. Okay, you all can leave now. One second, I just download that and. Okay, you all can leave. We'll repeat this once again. In the next class, I'll repeat this so that it will be more clear for you all.
Ma'am. Ma'am. Hello. Ma'am. Ma'am.